Hello friends, welcome to the second part of the lecture 1, that is Introduction to Power Electronics. In the last lecture we have seen some applications and some introductory video have been shown to you so that you can get some idea that what is a power electronics and what is the role of that power electronics in our industrial application as well as the residential application. Now next let us start with this particular diagram. So as shown in this particular diagram, what we can able to see is that power electronics is basically a multidisciplinary branch where there are three things involved. One is power and engineering, power and energy, electronics and devices, and third one is system and control. So power electronics can be considered as a subject which can control the amount of power in terms of megawatt or in terms of milliwatts or microwatts also, which are working on the basic fundamentals of electronics, that is electronics and devices, and third one is control. Students, if we have power and we have the semiconductor physics principles also with us, but if we are not having a control over there, then it will not be possible for us to use the power electronics devices as well as the circuits. So this part, that is the control part, is very important. Power and energy consist of energy processing, motor drives and power supply. Particularly as an electrical engineer, we always try to control the motor in an efficient ways rather than the rheostatic control base. Power electronics basically works on the fundamental of electronics, that is electronic semiconductor, that is power semiconductor. This power semiconductor is nothing but the electronics fundamental, like a p-n junction diode or the transistor is there, but at the power level. Then magnetic circuits. Okay, what is the effect of those devices on these magnetics, that we have to learn or include while learning the power electronics. Similarly, switch control as well as the without feedback and with feedback system that we have to control in our power electronics. So basically what it wants to tell is that it's a multidisciplinary, interdisciplinary branch which consists of power, electronics as well as control. So hope you can able to understand that. Now next part is that what is the need of power electronics, means that what is the need of a switching. So as shown in this particular diagram, let us try to understand that with a diagram. What we are having is a DC to DC converter or a chopper. We are having a voltage source of 24 volt and what we require is at the output we require a 12 volt. So what could be this particular network? So this could be a resistance control, or by using a switch control we can able to get this 12 volt. Okay, so if we are having 24 volt over here and if we want 12 volt over here, then there are two methods by which we can able to get that. That is resistance control, means that we may have some resistance over there, and then a switch control, means that we are having a switch instead of that resistance. Now the question arises over here is that which is more useful. So let us try to understand the first type of control, that is the resistance control. So as in the previous diagram, what we have is that we are having 24 volt and here we want 12 volt. So obviously what we can able to do is that we can have some voltage drop across this resistance and finally we'll get 12 volt over here. Okay, so this is one of the solution, and if we can consider this as a resistance fixed, then RL can be changed according to the requirement. So variable is also possible, even though it is also possible to have this variable resistance. So we can able to get the required amount of voltage, and according to that some current will flow and required amount of power can be transferred from source to load by using this type of circuit, which we generally use in our basic DC motor application, that is rheostatic control in armature or a field control. If you want to control the speed of a DC motor, then what we are generally doing is that we are just connecting a rheostat in between the armature circuit, or we are connecting a rheostat in the field circuit to get the variable speed. So this is the control, but here the problem is the efficiency. As per the maximum power transfer theorem, we can get the maximum power transfer when RL is equal to R, that is the internal source resistance is equal to the load resistance, and at that time if we are finding the efficiency, then the efficiency cannot be greater than 50%. So the major disadvantage of using such a resistive control is that whatever is the power loss over here, that is very high, and similarly the efficiency part, the power delivered to the load, the efficiency part is also very less. So we cannot get more than 50% of the efficiency for this power transfer. So this we should not use, as the power electronic devices are there. Now as I have told you that each and every power electronic device will going to work as a switch. So this is the control that we can able to get. What we are doing is that by controlling the power delivered to load by using such a switch. So what we are doing is that we are controlling the power through switch, which is also called as a duty ratio. Now what is that duty ratio, that we will able to see in the next slide also, but let us try to understand the first working of this particular switch. Now when the switch is closed, maximum whatever is the power over here, that will be transferred to this load without any losses, considering that this particular switch is ideal switch. Okay, even though it's a practical switch, the losses will be very less. Only the switching losses will occur, and the conduction and the blocking losses will be very less as far as the power semiconductor switches are concerned. So what we are doing is that when the switch is closed, the maximum power will be transferred to the load, and when the switch is open, at that time there is no power, means that power cannot be able to transfer to the load. So here the situation is somewhat good, means that whenever we want to transfer the power, at that time losses at the switch will be very less, but at the same time what we are getting is that when the switch is off, we are getting a 0 volt, but in between we cannot able to get, means that suppose I require a intermediate power transfer, then it would not be possible. So the solution to that is this particular type of control, that is called as a duty cycle control or a duty ratio control. So the advantage of using such a scheme is that very less amount of power will be lost in this switch. Okay, still we can able to transfer the power. Okay, so let us try to understand what is a duty cycle. Now our basic problem in the previous circuit was that we cannot get some intermediate range of the power transfer from source to load. So what we can able to do is that we can have some duty ratio control or a duty cycle control. What this is a voltage, and this is a timeline. X axis we are having time, and y axis we are having a voltage. Okay, so the switch is closed for this to this time, that is up to dt time the switch is closed, means that the switch is on, and for this dt to t time the switch is off. Okay, and again the switch will be turned on at t is equal to capital T and up to next dt plus t plus dt. So here the switch is on, here the switch is off, again the switch is on, off. We can have some constant frequency operation for this particular duty. So this is called as a duty cycle. The equation of duty cycle is T on upon T on plus T off, means that T divided by capital T, where capital T is nothing but T plus T off plus T on. Okay, so what we can able to get is that if we can able to vary this T on, or even we can vary this T off, then some average value of the voltage that we are getting at the output or at the load side. So just by changing the turn on time of this switch or turn off time of this switch, we can able to get the required amount of voltage transferred to the load, and thus the power transferred to the load can be changed. We will study this particular circuit in detail in chopper, that is a DC to DC chopper, and again we will see in depth what is this duty cycle or duty ratio control. But here just you understand that when the switch time is higher, if the on time is higher, then the output will be high, and if off time is higher, then the output will be low in terms of power. So hope you can able to understand that switch control. Next, here what we have done is that we are using a switch. Okay, so let us try to understand what this basically switch is. In the next part, we are going to study the characteristics of ideal switch. As I told you that each and every power electronic device is going to work as a switch. So in the next part of our introduction chapter, we are going to start with the characteristics of ideal switch. Thank you.